Hello, and welcome to Sequences and Series. So this is kind of like the second part of Unit 4. The first part was all about systems of equations. This second part is all about something called sequences and series. So it's got its own little set of lessons. And then we combine the two almost like mini topics to make Unit 4 up. So today what we're going to learn is we're going to learn about something called arithmetic sequences. You're going to find it's actually pretty easy. So it's kind of just about patterns. So when we talk about a sequence is just a pattern of numbers. So for instance, like this is a sequence, right? It goes 1, 2, 3, 4, 5, 6. And you notice that there's commas after it. The patterns could be increasing, decreasing, as long as it's just a number followed by another number, followed by another number that goes in some sort of pattern, we call that a sequence. These sequences could be finite sequences or infinite sequences. A finite sequence means it ends. Okay, so when we have a finite sequence, there's a finish to it. This is a finite sequence because it goes 1, 2, 3, 4, and it stops. An infinite sequence is a sequence that doesn't stop. So an infinite sequence would go like this, 1, 2, 3, 4, and then dot, dot, dot after it. That dot, dot, dot means it goes forever. So that sequence would keep going 5, 6, 7, 8, all the way up until infinity or just forever. Perfect. Today we're going to deal with arithmetic sequences. Arithmetic sequences means that we are adding or subtracting, okay, to get our pattern. So for instance, if you went from 1 to 3 to 5 to 7 and you're going up by 2s, that's an arithmetic sequence. The difference, or whatever we're adding or subtracting, is called our common difference. Okay, and that's a term you're going to need to know. We can have common differences that are positive. We can have common differences that are negative. Okay, so if we look right here, this that I'm highlighting in red, that's an infinite arithmetic. I say arithmetic sometimes. I'm not sure why. That is an infinite arithmetic sequence because it goes forever. So it's infinite. That's what those dot, dot, dots mean. And it's arithmetic because it's counting by adding 2 every time, right? It went 2, 4, 6, 8. The next would be 10, 12, 14, 16, so on and so forth forever. In an arithmetic sequence, there's some certain things we need to talk about. Some important things are the common difference. So this one right here would have a common difference of 2. Awesome. It's written right there for you. Other things that we need to know about this sequence. We usually talk about the first term of the sequence. That's typically pretty important to us. 2 is the first term. The way that we represent that is by writing this. That means term number 1. This right here would then mean term number 2. So in general, we have this sequence right here, this format. That means the nth term. So if we wanted to talk about like the 100th term, we would go T and then put 100 where that little n is. Awesome. General term or formulas for these questions kind of look like this. This would be called the general term. We're going to get more into that when we talk about formulas. The reason why that's the general term is I could pick any number for n. Say I wanted to calculate the 20th term. I could change that n to be 20 to mean 20th term. And if I put that n in as 20 and then calculated, that would tell me what t of 20 is. So for instance, if I wanted to find the 20th term, I would use that formula, change n to be 20, and then put it in my calculator. This means that the 20th term is 62. So instead of having to count all the way up to the 20th term, 2, 4, 6, 8, all the way up, I could just use this little general term formula to figure out what something is. We are going to have a formula to be able to use arithmetic sequences. We just haven't got there yet. Okay, let's try to create a couple sequences. We'll just do some basic ones. So we're going to just create a couple. Sorry, I just got interrupted. We always have to know what our first term is, so t of 1. In this question, it says develop a sequence starting at 5. So that means t of 1 is 5. The first term is 5. So we'll start with 5. Then it says we want to increase by a common difference of 3. Because we're increasing, that means we're adding 3. So if we're increasing by a common difference of 3, that means we are adding 3 to get to the next number. So the next number would be 8. If we added 3 again, the next number would be 11, and so on and so forth by adding 3s. I'm just going to put dot, 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 because you can keep going. Perfect. Simple, right? So we could do this again, except now we're going to decrease by a common difference of -4. So that means we have 5 as our starting number. We're now going to subtract 4 to get the next number, which would be 1. Then we're going to subtract 4 again to get -3. Subtract 4 again to get -7, and so on and so forth. Awesome. We have a sequence here. It says in the following sequence, -4, -1, 2, 5, and 8, we're going to figure out a few things. First thing we're going to figure out is this finite or infinite? Finite means it stops. Infinite means it goes forever. This one goes forever because of the dot, 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 so it is infinite. Perfect. The next thing asks us to find term number 1. That could be written as T1, as well as term 4. Term 1 is -4. This, in the blue, means the fourth term. So this is T1, this is T2, this is T3, this is T4. The answer would be 5. Awesome. The last question asks us to find the sixth term. The sixth term, if we kept going, T5 is 8, T6 we don't know. So to figure that out, we are going to have to figure out what the common difference was. If you look, the common difference from one number to another, I am adding 3. So if I was to add 3 again, that would give me my next number, which is 11. So T of 6 equals 11. Awesome. Hopefully you're getting it. It's really not that crazy hard. Just take some practice. Okay. This question, determine the first 2 terms of the sequence. So you're trying to figure out what would go in these 2 blanks. To be able to do that, you have to figure out what the common difference between these numbers is. So you're trying to figure out, how did I get from 8 to 13? You might be able to look at it and be like, oh, okay, you just added 5, and that's the way to do it. And if you look, you could actually add 5 to all of these, right? Because it's the same number that gets you from one to the other. It's all plus 5. But if you don't know, what you could do is you could take one term, like 13, and subtract the term ahead of it. So T of 2 minus T of 1, that's actually T of 4 and T of 3, sorry. The fourth term minus the third term would tell you the difference, which in this case is 5. I can work this pattern backwards to figure out what would go in those 2 blanks. So if I'm at 8, I want to go backwards. Instead of adding 5, I would subtract 5 to give me 3. To go back again, instead of adding 5, I would subtract 5 to give me -2. So my first 2 terms, T of 1 is -2, T of 2 is 3. Like that. Awesome. We'll get into the formula and do a couple harder questions. So there is an arithmetic sequence formula. This is the formula. It will be provided to you on a test. Maybe I'll email you out a formula sheet so that you guys have it. It'll be for the whole year, but you'll find these formulas on there. This is for arithmetic sequences. We're going to learn a few formulas, so make sure you get them down. When looking at that formula, T of n is the general term, T of 1 is the first term, n is the number of terms that you're looking for. So if I want to look for, say, the 20th term, then n would be 20. is whatever goes in this spot right here. Right? These two numbers have to be the same. And D is the common difference. So for instance, if we look at this question down here, if we just want to talk about random parts of it, T of 1 would be 12, and D is the 4, is the common difference. The question then asks us to figure out what T of 19 and T of n are. We'll start with T of n. So if you wanted to calculate T of n using this formula, we would put T of 1, which is 12, plus we don't know what n is, so we leave it as n. We subtract 1, and then we multiply it by 4. If you want to write a little multiplication symbol, you can. That's called the general term. We can use that general term, that formula, to calculate T of 19, which is what it now asks for. So to calculate T of 19, we now change n to be 19. And we do that throughout the whole question. So this would become 12 T of 1 plus 19 minus 1 times 4. You could try throwing that whole thing in your calculator. I prefer to break it down. So this would be 12 plus 19 minus 1 is 18, and then times 4. That you can put in your calculator. So if you want to do 18 times 4, and then add 12, that tells you the answer is 84. So T of 19 equals 84. These formulas are going to become important when I start getting to questions like, what's T of 200? Right? You won't have time to write out all 200 things to try to figure out what it is. Instead, we just use this formula to be able to find terms. Cool. This question, how many terms are in this finite sequence? How many terms? There's different ways you could do this. One way you could do it is you could try to write out the whole sequence and figure it out. Yeah, you could do that. Or what you could do is realize that they've given you a bunch of information here. They've given you T of 1. They've given you T of n, but you don't know what that actually is. But n equals the last term. And they've also given you the difference. So if you look in between these two numbers, you see that plus 5 is the difference. So with this information, I could actually go to our formula being T of n equals T of 1 plus n minus 1 times d. And I could fill in most of this information except for the n value, and n would equal the last term, which tells me how long a sequence is. So if I wanted to fill this in, T of n is 152. We don't know what n is, but I know that it's 152. The term is 152. That's equal to T of 1, which is -3, plus n, which we don't know, minus 1, times d, which is the common difference of 5. And what you've done is you've created a formula where n is the last term number, and you have only one variable in that equation, which means you could solve for that one variable. To do that, I'm going to move everything to the other side. So I'm going to add 3 to both sides. That gives me 155 equals n minus 1 times 5. I then could divide both sides by 5. When I divide both sides by 5, I get 31 equals n minus 1. And then I add 1, which tells me 32 equals 1. That means, not equals 1. 32 equals n, which means this was the 32nd term, and that was the last term, which means there are 32 terms total. Perfect. If you look at the next question, it says which term, so you're looking for n, has a value of 117. That means t of n equals 117. You're looking for n. So I want you to try to pause. Maybe you can use the formula yourself. It's kind of like the question we just did. See if you can solve for which term is the 117th term. Okay, hopefully you did that. I'm going to fill in all those stuff. So I'm going to use my formula, which is up here. T of n is 117. That is equal to t of 1, which is 3, plus n, which I don't know, minus 1 times 5. I'm going to solve for n. So I'm going to subtract 3 first. Oh, not divide by 3, subtract 3. That gives me 114 equals n minus 1 times 5. If I go 114 divided by 5, I get 22.8 equals n minus 1. I add 1 to both sides. I get 23.8 equals n. Now, with n has to be a whole number, right? I don't have in-betweens. So if you look at this pattern, it goes -3, 2, 7. There are no terms in between. That means n has to be a whole number. So if you get 23.8 as your term value for n, it means 1, you either made a mistake, or 2, that term doesn't exist. I am just quick looking at it right now. I made a mistake. My mistake is that my t of 1 was actually -3, which means I should have been adding 3, which means this is actually 120. And I can't edit this video, so you're all just going to have to bear with me. And when I divided both sides by 5, I should have got, I think, 23. 120 divided by 5, 24. And then when I added 1, I should have got 25. That means this is the 25th term. T of 25 equals 117. Sorry for that. Hopefully you didn't make that mistake when you're doing it. Awesome. Okay. We have 2 questions left. 3. 3 questions left. This one says the first term of an arithmetic sequence is 22 and the fifth is 74. Find the second, third, and fourth terms. Different ways to do this. What I like to do is I like to write out the info they just gave me. So they told me the first term is 22. So T of 1 equals 22. The next thing they told me was that the fifth term is 74. T of 5 equals 74. That means n equals 5. Right? They gave me this like random piece of information right here. They gave me a t of n. They said t of 5. And so I can use t of 5 as a value, and I can use 5 as my n. What they never gave me, though, was my d value, my common difference. I don't know what I'm going up by. I don't know what I'm going down by. So what I'm going to do is I'm going to use all of this information, put it into our formula, which is t of n equals t of 1 plus n minus 1 times d. And I'm going to put all those pieces in and then isolate for d. So when I put in all those pieces, I'm going to have 74 equals 22 plus n is 5 minus 1 times d. I'm going to calculate this first to make this 74 equals 22 plus 4 times d. And then I can start isolating. So I'm going to move my 22 over. That gives me 52 equals 4d. And then we divide by 4. Remember, the order in which you do things does matter. I'm going fast through it because we should have been practicing that all semester. But the order in which you move things to the other side does matter. When I divide by 4, I get my D value is 13. With that information, I can now figure out the second, third, and fourth term. There's different ways to do it. All I'm going to do is I'm going to say T of 1 is 22. T of 2 would then equal plus 13, which would be 35, right? Because I just found that the difference is plus 13. That means T of 3 is 48. T of 4 is 61. I know that because all I'm doing every time is I'm adding that difference that I just found. Awesome. This one, a little bit harder. There's two different ways that you can approach these questions. I'm going to show you both ways. Okay. One is a little more mathy, one is a little more tricky. So for this first one, I'm going to use a little bit of a trick to solve this. It says find the missing terms for this finite sequence. They gave me T of 2 and T of 3, 4, 5, 6. My formulas, this T of n equals T of 1 plus n minus 1 D. That's the formula. And you'll notice that the only way you can use this formula is if you have a T of 1 value. If you don't have a T of 1 value and you don't have a difference, which in this case I don't have both, then you're kind of in trouble. So what I'm going to do is I'm going to go back to this sequence and I'm going to pretend this is T of 1. If this is T of 1, that means this is now T of 2, T of 3, T of 4. This is T of 5 right there. And now I'm going to do this question as if this is T of 1 and this is T of 5. And then once I do that to figure out what the common difference is, then I'll go back to the original question and start filling in the blanks. So to do that, I'm going to put T of 5 equals T of 1 plus 5 minus 1 times D. T of 5 was 30. My new T of 5, right? Which equals T of 1. My new T of 1 is 14. Plus 5 minus 1 is 4 times D. If I move the 14 over, that gives me 16 equals 4D. If I divide by 4, that means 4 equals D. That means this sequence happened by adding 4 to each spot. So that would mean this is 18. If I added 4, this is 22. If I added 4, this is 26. If I added 4, I get 30, which is correct. To get the last one, I'm going to subtract 4. That means this must have been 10. So that's the more like tricky method to solving a question like that where they don't give you T of 1. All I do is I take whatever they first gave me, I make that T of 1, and then I go on from there. I could do the same thing with this question. So it says determine T of 1 and D for this arithmetic sequence. And they gave you T of 10 and T of 27. So you could do this trick again and say, we're going to pretend this is T of 1. That means this would be T of 18. And then I'm going to do the question as if those are the numbers, just so I can find the difference. And then I'm going to use that difference to find out the real T of 1. That's one way to do it. The more mathy way to do it. Is to use systems of equations. So each one of these values, So T of 10, for instance, gives me a formula. It tells me that T of 10, which is 50, equals the first term plus 10 minus 1 times d. Not sure why I wrote 10 so small. The other term, 27, also gives me a formula. It says that 152 would equal the first term plus 27 minus 1 times d. What I've done is I've taken both of those random terms they gave me and I've put them into my formula. The reason why I'm doing that is because now what I have is I have a system of equations. I have two different equations. I have the green one and the blue one with two unknowns. And those unknowns are the same thing, T1 and D. T1 and D. So that means I could solve this equation using any of the methods we learned previously. So early in this unit, we learned elimination, substitution, and graphing. You could use any of those methods to solve this. This question, if you do a little calculation, nicely fits elimination. So I have 50 equals T of 1 plus 9D. If I calculate the brackets on the blue one, I get 152 equals T of 1 plus 26D. If I do elimination, I write one on top of the other one. So I'm going to move the blue one over here, 152 equals T of 1 plus 26D. Looking at these equations, I would subtract them, right? By subtracting, that's going to get rid of my T of 1 term. So 50 minus 152 is negative 102. T of 1s would cancel out. 9D minus 26D would give me negative 17Ds. Awesome. At that point, I could solve for D by going negative 102 divided by negative 17. I'm just doing some math now to make sure I'm right because I don't trust myself right now, which tells me that 6 equals D. I got that. I probably should have written it by dividing both sides by negative 17. Awesome. I now have the first thing it asked me for, which is D. The second thing it wants me to solve for is T of 1. To do that, I take my answer for D and I substitute it back into one of my equations. I'm going to substitute it in that one. And then I try to get T of 1 by itself. So I have 152. So I have 152 equals T of 1 plus 26 times 6. That means I have 152 equals T of 1 plus 26 times 6 is 156. If I subtract that value from both sides, so I subtract 156 from both sides, I get negative 4 equals T of 1. And that is my second answer. So my two answers are D equals 6 and T of 1 equals negative 4. That's the more mathy way to do it. We use systems of equations. You could have also used the same trick we use on this slide where we would have called T of 10 T of 1 and we would have called T of 27 T of 18. And then we could have done something similar to this, which would have helped me get the D value. And then we would have had to use the D value to calculate the T of 1 value. Awesome. I hope you enjoyed your first taste of sequences and series. Take care.